we go. All right. So, welcome. As we said, we're going to have a good amount of class time to think about doing the lab in class too. We want to have time for that and kind of answer any questions on that. But I did wanted to do a little bit of review and as we're thinking about the competency check for next week. And so just a reminder, we have our first like in-class quiz next week on next Friday. And you do need or it'd be helpful to have a calculator present. I guess you could do it by hand if you would like, but please purchase a calculator. And if you can't afford it or you're having trouble getting it to you to arrive in time, just let me know and we can see what we can do. But this week was D3 week. The lab is supposed to get you thinking very, in a weird way about diversity. Not weird, but just different. I was trying to think about how to discuss diversity in stats. And so the lab tries to get you to think about diversity in different ways through the data set. But we'll get to that in a little bit. So this is just from this weekend. So our data already look much different. But let's just remember, what kind of distribution does this look like? Yeah. Positive or a right skew, right? Great. So this is the proportion of people of videos watched in our class, but instead we don't want to have a positive right skew. What kind of skew are we looking for when it comes to videos watched? Yeah. Why negative skew? Great, right? We want to see like everyone's watched the video, so everyone's like all the proportion of videos watched. Everyone's really high up, right? So, awesome. Okay, so we started the semester talking about frequency tables, and then from there we moved on to the three measures of central tendency: mean, median, and mode. Mode, median, mean. Um, what are like the benefit of using the modes? The modes one like we don't see pop up a lot, but that doesn't mean it's not useful. Like, what is the benefit of reporting a mode? Like, what does the mode tell us? And the others maybe don't. Good. So the most common, right? And we're not really finding that out via the median or the mean. So the most common can be really helpful. There are times where we probably can't get a average of something, but we might want to know what is the most common of that thing. Anyone think of an example of something that we would want to know what is most common? Eight hours of homework.
A lot of people said they spent like 30 minutes.
Okay, that would be, but we could probably get an average of that, and then like the average might be helpful to tell us too, right? Like, but what are things you can't take averages of? Qualitative answers, right? So something that's not numerical. What would be something not numerical that maybe you're looking for colleges and you want to know something not numerical about a college? What percent of campus? How many?
how good the food is.
We get that on a rating scale of 1 through 5.
Terrible, very good.
But then would you get an average, right?
I don't know.
I was thinking like you could get polls for an election,
Okay.
if you want to see like who got more votes.
Sure. Yeah, right? Because like that's just like a adding up, right? Like it's just like, well, who got the most common votes, right? Like the most, who was voted most often, right? So, and so that would be a non-numeric variable because you're counting names, right? Like, was it, Donald Trump, DT, or, oh, no, right, sorry, almost blank, right? Right? And you can't really get an average, like the average vote was to something, right? Like, and it probably doesn't make sense to say like the average gender on campus is something. And like, no, you just say like the most common gender is this, right? 51% of campus is, 70% of psychology majors are. It's not really an average, you're just telling me what's the most common value, right? So mode is good for thinking about things that we can't really take averages of. But it also just, it tells us an actual data point, right? Like whatever the mode is, exists in the data. Why might a median not exist in the data? When could it be that you tell me the median and I'm like, that's not a number in this data set? You gotta take the average, right? And so if it's 1, 3, 5, 7, the median is what? 4. The median is 4. That is not a value in this data set. And the same thing for a mean. Mean divided by 4, something like 3.5. That's not a value in the data set. Mode will always be there. It's always there for us. So the mode is also will always be part of the data. It's real. It exists. It's always able to be seen. Now, as I said, we don't use the mode a lot, so what are some negatives? Why? What does the mode not tell us, or why is it not the thing we report a lot of the time? Okay, good. I mean, like, it doesn't tell us much, right? Like, all it's really telling us is frequency, right? Like, so no outliers. Like, it only cares about frequency. Right? Frequency, which sure is useful, but when we have millions of observations, like, do we really care frequency of that? Maybe. So like, because there's like not many outliers, like, yeah, sure, we could have a lot over here, but we're kind of forgetting about all these guys that could still be really important, right? We miss out on that. So, no distribution. Um, I had listed this as a data set but we also could imagine what if it was something like are both of those kind of weird for mode. Say, what is the modal value? What do you say? This first one.
Oh.
Sorry. Wait, the second one too. All right, yeah, we're going with the second one first. Great. 1 and 3, right? And I was like, yeah, but I wanted 1 value. Why are you telling me 2 values? You didn't answer. You answered the question, but it's not a question. I wanted to know what is the mode, and you're like, there are 2. What do you want to do? Whatever you want to do. And you're like, that's not an answer to the question. And so yeah, like one problem is it might give us multiple modes, which is kind of annoying. Not necessarily the answer to what is the mode. And so this problem is that you can get multiple. Continue then.
There's no mode.
There's no mode, right? Or the answer is blank, right? Or none. And that's fine. And then it's doing nothing for us, right? It's not describing the data. Its answer is there's no mode. Okay. Thank you for being useless. So that's our mode. What are some helpful things? Why is the median a good thing? Benefits of the median have.
Like there's a nice outlier in that.
So it's I mean, resistant to outliers. Because the outliers aren't really going to affect it that as much. It's not getting pulled up because there's a really high value. We're trying to remind ourselves what outliers means, right? Outliers suggest skew. Definition, what does the median represent?
The middle.
The middle, right? Like that's nice. I ask you like, what is the mean or the middle of this data? Like it tells me something. So using the middle values is nice. Again, when we're thinking about that distribution, we said, well, for a mode, this might not actually represent missing out on a lot. Well, the median saying, okay, well, I'm going to care about this. Not really that far, but. All right, what about some problems of our median? Right, right. So exactly like kind of the opposite. We can look at the mode and say, well, if that's a positive, it's going to be a negative of the median, because sometimes it's not a part of the data, right? Not always a value in the data. And if it's less affected by skew, that can be a good thing. It also can maybe be a bad thing.
It doesn't take like the outlier into consideration, but it's still like a number, a part of the data.
Right, like it ignores the outliers, ignores the outlier in a way, which suggests that like we're ignoring part of the data. And that's sad. Never ignore data. Data's there to teach us something. Okay. So that leaves us with our average, our mean. Yeah. This is all the data. Everyone gets treated as equally important. And because it's an average, we had kind of found this out in a roundabout way with our deviation scores. What happens if you just added up all the deviation scores and you forgot to square the deviation scores when we're trying to calculate our variance? We have like the x minus m, have our x minus m, and then we immediately kind of move to x minus m squared, or x. We have some value, and we have to square it. Why do we have to square it? What happens if we added up all of these values? Anyone remember what might happen? It equals 0. It equals 0. And so that's actually a benefit of the mean. Basically, it's saying that when you look at the average, half of things are going to be like, or the distance is equal. Half of the distance is on the left, half of the distance is on the right. The deviation on either side, if you add them together, will be 0. And so that's why we have to square it to make sure it's not 0. But most of the time, our data average is not a real value. When we ask people how they feel on a scale of 1 to 7, and then we say the average score was 3.5, but did anyone get to say 3.5? No, but the average score is 3.5. What does that even mean then? And you're like, oh, I don't know. I can't tell you. It's like, that's not great. And because it's taking all the data into account, it's also going to move based on those extreme values. And so overall, a big problem with all of statistics is that we're boiling down things to a single number, right? And that is a problem for central tendency. It is really going to be a problem throughout the class where we're going to say things are significant or they're not. And it really does not tell us enough. The limitations of all these things is that none of them tell us the shape of our data and their distributions. And we fail to think about what actually might be most common. And what I, or less common, but even, in a data set that was 4, 4, and then 1, 2, 5, 6, 7, 8, 9, 10. Like, yes, the mode is 4. But in saying that, we've kind of forgot that everyone else exists. Like, it's both going to underrepresent less common responses and potentially overrepresent the most common response. So that's our conclusion and review to the central tendency stuff. Questions on that? All right. So then we had watched some videos on Wednesday and today about graphs. So here's a graph. Now we're going to get a little bit more into thinking about how does these 3 weeks and that kind of merge together. So here's a graph. It has 3 lines on it. The solid line is cognitive psychology with a circle. There's a tiny dot line with squares, that's developmental, and dashes with triangles, that's social psychology. On the x-axis, we have the decade, and on the y-axis, we have proportion of publications. And the title says, how often is research that highlights race published in psychology journal? So what are some things you see in this graph? What is this graph trying to show?
Like, it's like, yeah.
Good. So you're noticing that developmental is our square one. It's growing the most. It's very generous of you, but yes, has the most growth. Good. What else do you think? Yeah. Had no movement at all. Good. More than no movement at all. What else do we see about cognitive psychology? So breathe, it did not move. Did not move from what? 0. Right. So 0 publications highlight race and cognitive psychology from 1970s to 2010. Now that we're looking at that y-axis, what else do we notice about this graph in terms of research highlighting race? Yeah. Sorry, I didn't hear you. There's a dip in the 1980s. Yes, there is. Good. So it kind of like it started out here and we kind of went down a little bit to the 80s. Nice. Is it a lot? No. Why do you say no? Why are you looking at this and saying, that's really not that much? How much is it? Proportion. So, what does it mean to have a proportion of 10? Hmm? Potentially, we could be struggling on this question. because of my second question on this actually, based on what we've learned, there is a problem with this graph, particularly on the y-axis. What do you know about?
Goes up too high. It was smaller.
Not necessarily that. Mathematically, there's a problem with this graph. Proportions are from 0 to 1. Proportions are from 0 to 1. If they wanted to use 10, 20, 30, 40, 50, what word should they have put here instead of proportion? Percent. When we're thinking of our frequency tables, proportion is a number that goes from 0 to 1. Percent is a number that goes from 0 to 100. So now that we know, this is showing the proportion of publications, and we fixed it, or we can say it's actually showing the percent of publications. How much percent of publications in psychology have highlighted gray? Yeah. 10%, right? A little over 10% of all papers have been published that study race or highlight race, really engage with that conversation. That is pathetic, right? For something that is so like ingrained in our social fabric, we only talk about it 10% of the time. Now, here's a different graph. Same problem with our y-axis. It says proportion. Please read it as percent. But we have something going down the middle here. We can look at the left side. This is authors of color versus white authors. Okay, so same graph, just one is for you have somebody on your authorship team who is not white. You have someone, everybody on your authorship team, everyone wrote the paper is white. And then over here, it goes from 0 to 100. And it says this part of the rectangle is the participants of color. And this part of the rectangle is your white participants. So in your study, what percent of your participants were white and what percent of your participants were not white? So we look at this. And what is our takeaway that we think? There's a bunch of takeaways. Like, what's something that you noticed here?
The color, race, but then social psychology, it's a little bit more even, but still almost kind of race more than white authors and social.
So, love it. It's just it's not highlighted race, it's what proportion of them have participants of color, right? So you noted that there's a big difference here if we look at these two, right? So we have cognitive over here and cognitive over here. We have authors of color. What proportion of their participants are participants of color? That's the question. So this one, what proportion of their participants are participants of color? Okay. 0.75, right? Nice. Thank you for speaking in terms of proportion. So that means 25% of their participants are white. When we look at white cognitive psychologists, what is their proportion of participants of color? 0.4. Good estimate here. So that's 0.4, that's gonna be 0.6. Big change. And that changes the kind of conclusions we're going to make, who we're speaking to when we're doing this research. And the same thing Brooke noted occurs here. So developmental to developmental, we have big shifts. And social as well, but at least, I don't know. In some ways, hey, we're equal. Well, what's actually a bigger problem for social psychologists to think about? Look on either side of this line. What is different about social than developmental or cognitive? They're both low, right? Like our number here for social, I'll be generous and say 30%, or sorry, 0.3 proportion. Guess that looks more like 0.16. That's not good, right? Only 30% of our sample are people of color, compared to every other individual, much more, right? Like who is being represented in our study can really change how the kind of conclusions we make, who we're speaking to, how we're making these conclusions. This was a huge paper that when I reopened it and then saw, like for this class, when I saw it said proportion, I got really excited, but also like, come on, how did we miss that? So let's think about how our central tendency can go wrong. This is a data set, and it is asking people to report their experiences of discrimination. And we find out that the mean reporting from 1 to 5 was a 2.29 on discrimination, a median of 2.2, and a mode of 1. So that's all we need to know, right? That discrimination in the United States is at a 2.29. That's the amount of discrimination people experience. I've totally understood everything about discrimination across the United States. Why might this 1 point of central tendency not really be cutting it? What might I be missing? You might say, I think it'd be important to know who is experiencing a discrimination. Why? Why would there be who would experience discrimination differently? They're probably going to experience it very differently than the majority group. And so we actually probably want to know the breakdown of what is your racial identity and what are your experiences of discrimination. I think it was on a scale of 1 to 7. Now I forget. But then we can start looking at this and say, all right, I'm starting to notice some differences on this graph without really even knowing much about the numbers. Right? Like I look at this and I see things. What are some things that you see in these distributions? Do you see any differences? You know, it's a small graph, so we kind of have to imagine them be square. But okay. I guess we're trying to think about who experiences discrimination the most. Then for me, I want to know like who experiences like the most discrimination. So I'd be looking to the end of the tails, right, where it's high, and trying to figure out like are there differences there? Is one tail thicker towards the end than the other? Okay.
they have a bump.
Mm-hmm. And you're noticing like, there's a bump out here, like there's still like some bumps going on here. The other has those bumps. And the multiracial too, like that kind of consistently stays up pretty far out. I guess there's a bump there too. Real quick. Good. Sorry, your water bottle is like blended into your shirt. Right, so like we can look at this, and we don't know much, but we can say it looks like there's something happening out there in the tail for these groups. We also can look on the other side too and say, okay, well, this, like the Asians in the reporting low. Now, this is where statistics gets messy because it's one thing then to conclude they don't experience discrimination. But second thing we have to consider is always, how did we get this information? I want to know how much discrimination you experience in your life. How do I find that out? I want to find out how many brothers or sisters you have. How do I find that? I have to ask you, right? Like you have to tell me, right? There's a social interaction that is occurring in this moment to find out this information. And so, could it be that Asian individuals do not experience discrimination? Yes. Could it also be that there's a cultural stigma around disclosing that, or how they recognize that, or how they want to talk about it to others? Also, yes. And so it's not so easy to look at data and then make a conclusion because you're forgetting about the culture of the individual who's there. And then when we stack all these, there's always a risk that they're all basing their heights off each other in this graph. So the heights of the bars, like I wish they were percents, but frequency histograms usually are in terms of frequency, the number, the count. And that can be dangerous to interpret as well. All right. So we have some graphs. Here's an example of a graph. This is their discrimination. I've just now flipped it and made it a little cleaner. This is one of our bar graphs. And so the height of these bar graphs represents the average amount of discrimination reported by each group. What could we, like, what is missing? What would be nice to know? Remember, right now, all I'm telling you is the average. Problem set, the last question had a graph. Kind of looked like this. It had something else attached to it.
What are you talking about the standard deviation?
Yes, right, the whiskers. Yeah. So we don't know like how varying this is, right? Like what does that mean? And we said like, well, it doesn't tell us the distribution, right? So standard error bars or standard deviation bars tell us something about how, there was that one that was like, right? Like how much variation is in each of these groups, right? We don't have that here, and we want to know, okay, you told me this one data point, but what does that actually mean? Is everyone clustered? Is every single person saying 2.2? Or is there some differences? So we could add some standard error bars or standard deviation bars. So now we have this, but potentially I've done something wrong now. I added those bars in. Now what are you thinking? What can we do better now?
scale the graph.
Why does it scale off?
It makes it look like really small. It goes all the way up to 6.
And it goes all the way up to 6. And so then we're like, oh, well, okay, everything is super small. And not only is it super small, it makes it look like everyone's pretty equal. Because it's going up so high, right? Yes, they could have set up to 6, but they didn't. So let's readjust our eyes to be able to see that difference that we had here and really be able to emphasize, like, wow, Asians in this data set are reporting more than half less than multiracial, and you don't notice that here. Right? And so there's a lot of problems when we're thinking about how we talk about data and how it can be harmful for individuals. So here's some examples of various visualizations. Here's one that says number of people shot to death by the police by racial identity. And so here we have in 2023, this data set shows 425 white individuals were shot to death by the police, 229 black individuals, 133 Hispanic individuals, 29 other, and there are 347 victims that we do not know the racial identity of. When we look at this, the question is, why might people use this data to say that police are not biased by race? But I'll move that numbers on top. 133, 347. We look at this data. Someone wants to use this data to say, look, police are not biased by race. How can they say that? Why would they be able to say that? The number of people killed by the police in 2023. What is some things you notice about the graph? Or yeah.
There's like a couple things, but
Okay.
one of them being that 347 individuals weren't identified. So like if they had bias, they would most likely identify as the race that they're biased towards.
Good. Yeah, that's actually a good question. I'm not sure what unknown, like who's doing the unknowing mean? Like, is it the police then saying, like, I don't know what race this person is, or is it the data set somehow just doesn't know what the race the person is? That's a good question. But yes, like if we had those 347 categorized, maybe this data looks differently, right? Good. Who is killed the most? White individuals, right? So you can look at this data and say, no, police actually are killing more white individuals than any other race in 2023. So they can't be biased against minorities, because if they were, then it'd be higher. Why is that conclusion, which what you would take away from this graph, incorrect? What are we missing? Yeah. Yeah, the proportion of minorities in the population, right? That, sure, that could be the case if, one second, I'm trying to make sure, I thought I had the correction, and I'm trying to see if I do. Yes, I do. Okay, good. I'm gonna just change the look a little bit. We have to think about, well, on average, a police officer engages with 70% white individuals. So we need to account for that, right? They're not engaging with everyone equally. And so if we say, okay, for millions of people, for every 1 million people that have this identity, how many per million were shot by police? fatally shot by police, so killed by police. So now we have this data set. Why is this data set or this graph better at showing the issue? Right now, it's accounting for that percent of the population of the whole group is. And now when we look at it, we do see that Black individuals are killed by police at much higher rates than white individuals. Right. There are other problems with, and so you're like, well, then do everything by percents. Well, percents can be bad too. And so here, this was from the Pew Research Center, and I love Pew. And so they mentioned that US murder rates rose by nearly 1/3, 30% murder rates increased in 2020. Holy crap. It was just a wild wasteland out there. It was like the purge. Right? We all engaged in the purge. And when they talk about murder rates, we do put it in terms of number of people. So how many people died per 100,000 people? But the real number was, it went from 6 per 100,000 to 7.8 per 100,000. So per 100,000 people, how many more people actually died? 100,000 people. And I said 6 out of 100,000 died. And then next year, I say the number is this. So how many people now have died? Two more, right? Yeah, it's now 2 more people have died. Murder rates rose by 30%, which means 2 more people died per 100,000 people. Does that feel like 2 more people per 100,000 have died? That graph not make me feel like only 2 out of every 100,000 have died. That makes me feel like it is insane out there right now. Very different. How we graph things can really tell different stories. We don't have a lot of time to get into this because I want to make sure you have time for your lab and ask questions. But I'll just say, right, there are other ways we can think about data. In this class, we're talking only about quantitative data. That is numbers. We rely on numbers to tell us the truth about things, and we do surveys and experiments to tell us this. I like to do both. And I and Dr. Aurora, she's our new faculty member, and Dr. Ernestus, and Dr. Royman, all also do qualitative research. And that is, we make conclusions based on interviews, talk to you, learn about your life, learn about the human experience. And it's important in thinking in terms of stats and diversity because feminist scholars and critical race scholars and Black scholars use qualitative research a lot, right? And they get some really amazing findings and conclusions that really change how we think about things through qualitative research. It's also basically what you all want to do with your lives. I've been trying to push this, that everyone wants to be a clinician and talk to people. And so here's a way to understand people by talking to them, and we don't teach it to you. And it just seems odd to me. Like, okay, but like their job, not their job. Their job, not their job. And then it's fine. So there are some pros and cons. I feel like the big pro for quantitative is it gives us a number, right? We get to say, like, these groups are different. So like number, it tells us like a solid conclusion. Qualitative is not meant to give you a clear answer because it's representing life, right? It represents life. When grandma sits you down and tells you a story about her life and she wants you to gain a meaning out of her life story, when I was a child, she's not giving you a rating scale. She's still hoping you can come to a conclusion about what her story means, right? Get that takeaway. So it's, yeah, I mean, it's life, it's real. But the problem with quantitative is it's not really real, right? Like, there is no such thing as the average person. Averages aren't a thing in life. We just are. We're people. But people would say that qualitative, there's no strict standard. You might do the same interview and come away with very different things. Your friend tells you a story and you're like, oh my God, can you believe them? And your friend's like, yeah, that was terrifying. Right? You just have different reactions, right? So it's not standard. It can be different. I tend to view that as a benefit. Others view it as a consequence or negative. And so there's risks, and I will always complain about the risks of quantitative mathy stuff and then turn around and immediately do quantitative mathy stuff. But it is that we are making this assumption that everyone knows and has the same agreed upon meaning of what a 1 out of 5 is, a 1 out of 7. But that is a meaningful thing for us to understand. And that the questions we ask are not biased by the people who make them. My favorite example, and it still hasn't got officially published yet, but there's this feminist scholar out of the University of Michigan, and she has a very simple study. On a scale of 1, meaning pro-life, to 7, meaning pro-choice, where do you fall? And you mark 1 to 7. And then she just asks you, can you please define what a 1 means and what a 7 means? And that alone shows that your 1 is not your 1. It's not your 1 either. And that someone's 1 is another person's 4. And someone's 7 is another person's 3. And it's all meaningless. We don't have an agreed upon definition for these scales that we use. Super cool. I love her. She's just really interesting in the work she does. Okay, so the lab is trying to tap into the idea of context and thinking about differences in individuals. Context for me in this lab tries to show up a lot in terms of just where's the researcher, right? So a lot of the questions, they have the AHS, that's at home survey. The person shows up to your house, maybe your parents are sitting right there next to you, and they're asking you these questions. Versus in school survey, the researcher then followed you to school, sat you down in a classroom, and asked you all these questions. And we would expect, if they're true, how much discrimination do you experience? Your answer should be the same in both places. But the data shows that they're not true. People have differences in how they're reporting at home versus in school. It's like, what does that mean? Why are you saying different things around your parents and your friends? And how is that maybe different based on your upbringing, your race, your culture, your values, a bunch of things, right? So that's kind of the plan to get you thinking about how even something like a number and where we're asking it matters. Diversity can show up really everywhere. Okay. All right. I'll be, I mean, I know, I apologize, we only have like 15 minutes, but I'll be here to answer questions for 15 minutes on the lab. And then feel free to email me with questions beyond that.